Have you ever stumbled upon a piece of digital art and just thought, how in the world did they make that? Well, today, we're going to pull back the curtain on a really captivating piece of generative art. We're going to see how just a few elegant lines of code can create something that feels, well, truly alive. So let's get into it and deconstruct central breathing expansion.
So the original title is Central Breathing Expansion, and right off the bat, the artist gives us one simple instruction: headphones recommended. And that's our very first clue. It tells us that the sound is every bit as important as what we see when it comes to creating this whole immersive experience.
Okay, so here's our game plan. First, we're just going to experience the artwork for what it is. Then, we'll start digging in. We'll dissect that visual pulse. We'll uncover the secret to its really organic feel. Listen to how it actually creates its own voice, and then reveal the trick behind its amazing 3D sound. And at the end, we'll put it all back together and see how simple code can really become living art.
When you first load this piece up, you see this wireframe cube, and it's just gently rotating in this black void. But it's not still, it's pulsing. It's expanding and contracting with this really slow, steady rhythm. And the sound, it feels like it's coming from the very center of the cube, rising and falling with every single breath. It feels less like a computer animation and more like you're just watching some kind of strange digital life form in a deep state of meditation.
All right, so how is that core breathing effect actually made? I mean, it looks so incredibly smooth and natural. You probably guess it's some kind of super complex animation. But the foundation of it all is, well, it's surprisingly simple. It's all rooted in one single, beautiful, mathematical idea. Believe it or not, this one line of code, this is the beating heart of the entire thing. It's the engine of the whole animation. What it does is it uses a mathematical function called a sine wave to generate a number that just smoothly goes back and forth between 0 and 1, over and over and over.
So, for anyone who's not super familiar, a sine wave is just this perfect, smooth, repeating wave. I want you to picture the gentle rise and fall of the tide, or a pendulum swinging perfectly back and forth. In the world of animation, this is the absolute go-to tool for making any kind of natural, cyclical movement. But there's a catch. A perfect rhythm can feel just a little bit mechanical.
And that leads us right to our next big question. If the whole animation is being driven by this perfect mathematical wave, why does the final result feel so organic and not at all robotic? How does it feel less like a machine and more like a living thing? Well, the difference is all in the subtlety. Look on the left. That's the pure sine wave. It's perfectly predictable, perfectly regular. But the artwork itself feels much more like what's on the right. It's got that bass rhythm, sure, but it also has these tiny, unpredictable little fluctuations that just make it feel real, like an actual breath. The secret ingredient here is a little bit of calculated chaos. And here it is. This is the code that brings in that chaos. This line is generating something called Perlin noise. Now, unlike pure randomness, which is just jarring and messy, Perlin noise creates values that drift up and down in this much more natural, gradual way. It's actually the same kind of math that's used to generate realistic-looking clouds or mountains or fire in video games. So here's the recipe. It's really 3 simple steps. First, the code establishes that perfect rhythmic pulse using the smooth breath variable. Then it generates a small natural fluctuation using that Perlin noise. And finally, it just adds them together. The result is the organic breath value, a beautifully imperfect, natural-feeling rhythm. Okay, let's switch gears and talk about the audio. Now, the sound you hear in this piece isn't just some pre-recorded file playing on a loop. No, it's being generated live, right inside your browser, and it is perfectly one-to-one synchronized with the visual breath we just broke down. This line of code right here, this is the bridge between sight and sound. The code takes that organic breath value we were just talking about, the one that goes from 0 to 1, and it maps it to a whole new range, a sound frequency between 100 and 800 Hz. So, what does that mean? As the cube gets bigger, the pitch of the sound goes up. As it gets smaller, the pitch goes down. They're completely locked together.
But the sound we're hearing isn't just one boring, simple tone. To give it more richness, more texture, the artist is actually using 2 separate sound generators that are playing in harmony. In the world of audio programming, we call these things oscillators, and they're basically the fundamental building blocks of any synthesized sound. And this little table here shows us exactly how that texture is made. The main oscillator, that's our pure, smooth sine wave sound. But then there's a second one, a sub-oscillator, that uses a triangle waveform, which has a slightly brighter, almost buzzier tone. You can see it's also a lot quieter, and this is the crucial part.
its frequency is always exactly half of the main one. That pitches it one octave lower, creating this beautiful, subtle harmony that gives the sound all of its depth.
All right, now for that final layer of magic. This is the reason the artist told us to wear headphones. The sound doesn't just feel like it's in your left ear or your right ear, it has a real sense of space. It feels like it's coming from a specific point right there in front of you, from inside the cube. So how is that illusion created? It all comes down to this one simple setting in the code. The audio panner, which is the thing that controls the position of the sound, is set to a model called HRTF. And this little acronym stands for a really fascinating piece of audio technology.
HRTF stands for Head-Related Transfer Function, which is a fancy way of saying it's a really complex algorithm that simulates physics. It models how sound waves literally bounce off your head and your shoulders and enter your ears differently depending on where the sound is coming from. By applying all these tiny delays and filters, it can completely trick your brain into hearing sound in a 3D space, all through a regular pair of stereo headphones. It's amazing stuff.
So we've taken apart the visuals, we've taken apart the audio, we've looked at the individual lines of code that control the pulse, that organic feeling, the pitch, the 3D position. Now let's just step back for a second and see how all of these simple, elegant parts come together to create this one cohesive, living thing.
When you put it all together, what you have is a system. A perfect sine wave provides that rhythmic heartbeat. Then Perlin noise sprinkles in the subtle imperfections of life. Two oscillators harmonize to give the whole thing a voice. Frequency mapping makes sure that voice is perfectly in sync with its body. And finally, HRTF places that living, breathing object in a virtual space right there in front of you. You know, none of these ideas are crazy complex on their own, but when you weave them together like this, they create a truly compelling experience.
And this really brings us to a final thought. When a developer can take these mathematical functions and audio algorithms and combine them, not just to solve a technical problem, but to create a feeling, a sense of life, of meditation, of presence, it kind of forces us to ask a bigger question, doesn't it? Where exactly does the technical implementation end and the artistic expression begin? At what point does a well-written program become its own kind of poetry?